Nate and Steph, we're Kurt and Lori. We live here but like to go hiking here. This is our camper and this is our truck. I retired this year and want to camp more, but don't enjoy camping next to our friends wearing NASCAR on their outdoor TVs. Unfortunately, this is us. But this could be us.
Well, Kurt and Lori, we can help with that. We're going to install a high-performance electrical system upgrade in your camper so that you can get away from those noisy campgrounds. And we're going to show all of you watching how you can do it too. Let's get started. Modifying the factory electrical system in your camper is easy, but if you do it wrong, you could damage all of the OEM equipment in your camper or worse. In this chapter, we're going to do an electrical system walkthrough so we know what we're dealing with and what to look for. I always find it easiest to start with the OEM factory battery, and that's right here on the front of the camper. Now let's head to the back and find the shore power inlet. The shore power inlet is right back here. Just a standard 30 amp shore power inlet. Let's head up to the roof to see what we're dealing with for solar. Up on the roof, there's not a lot up here, but we have plenty of room for solar, so that's a plus. The only thing to really pay attention to here is this thing over here. This is part of the solar ready feature of this camper, which is simply a roof entry gland with two MC4 connectors coming through it that are presumably wired to, well, somewhere down inside of the camper. The other end of those solar wires from up top are actually in this storage pass-through at the front of the camper. Those solar wires are coming down right here. And so we're going to be utilizing these whenever we install our new charge controller and solar panels. Because we're going to be spending a lot of time in this compartment putting most of our components on this wall. Now let's go inside and see what we're dealing with in there. Inside the camper, there's all kinds of lights and fans, and there's a little panel over here for controlling a lot of that stuff, but that really doesn't matter for our purposes. We just want to be able to deliver power to all of that stuff. And right down here is our 120 volt breaker box and our 12 volt DC fuse block. And the thing that I'm looking for here is where's the wire that is coming to feed this breaker box. And this wire is the wire that's coming from our 30 amp shore power inlet on the back of the camper up to this 120 volt breaker box. And this is an important wire because we will be splicing into this later in the video. Now this camper is pretty straightforward because it doesn't have a generator, it doesn't have any pre-existing solar panels, but the challenges that we're met with here are going to be dealing with the solar ready component of this system, which is going to make our lives easier because we don't have to run the wires from the roof down to where we're going to install the charge controller, but we do have to make those considerations, and we'll show you how to do that when we get to that chapter in this video. The other part that we have to worry about, to be honest, is how we're going to get the wires from the MultiPlus inverter charger that we're going to install at the front of the camper back to that wire that goes from the 30 amp shore power inlet to the back of the 120 volt breaker box. That's probably going to be pretty challenging. And that's pretty much all we have to worry about in this one. Should be a pretty straightforward process, and I'm excited to get started. So let's go. Here's the plan. We are going to add a 270 amp hour Battleborn lithium battery, a Victron Lynx distributor for power distribution, wire the factory 12 volt wiring to the Lynx distributor, splice in a Victron MultiPlus inverter charger to the factory 120 volt system, add 800 watts of solar, and upgrade the alternator charging. Let's get started. Wiring the battery bank will be the easiest task in this whole video because we aren't wiring the battery bank. Instead of 3 smaller batteries, we opted for a single 270 amp hour Battleborn GC3 lithium battery. Using one larger battery is a great way to cut down on wiring and space required, and installation is as simple as securing the battery to the floor or wall. Wiring the Lynx distributor to the battery bank is easy, but it does include a ton of small steps that, if missed, can throw off the settings of your entire system. Just follow the order of operations that we'll show you in this chapter and you'll have no issues. The parts that we're using in this chapter are from the EXPLORIST.life Lynx Distributor wiring kit and the EXPLORIST.life chassis ground wiring kit. We're using the full 5-foot sections of wire from the kit, so we don't need to cut them. In using the barrel of the lug for our measurement, we stripped the insulation from both ends of our positive wire and then repeated the process for the negative wire. Next, we crimped on our wire lugs and made sure that the lugs were positioned on the wire so that the wire isn't twisted when installed. Then we added our heat shrink for protection and strain relief, and then sanded our lugs, terminals, and Lynx adapters and wiped it all down with some alcohol. We attached the Lynx adapter to the positive bus bar of the Lynx distributor by putting the bolt through a washer, the Lynx adapter, the Lynx distributor, washer, lock washer, nut, and then tightened until snug. Then we put the master disconnect switch onto the Lynx adapter. We connected the 3/8" lug from the positive wire to the battery switch, and then snapped the back on the switch. Then we put the MRBF fuse on the MRBF fuse holder, and put the 5/16" lug from the other end of the positive wire on top of the MRBF fuse, and secured with a washer, lock washer, nut, and tightened. Then we attached the other Lynx adapter to the negative bus bar on the Lynx distributor in the exact same fashion as the positive one from earlier. Now with the loads and chargers side of the shunt toward the Lynx distributor, we attached the shunt to the Lynx adapter with the washer and lock washer on top of the adapter. On the battery side of the shunt, we attached the 3/8" lug from the negative wire. Then we grabbed the small red power wire from the BMV712 box, and it's way too long for our needs, so we're going to cut out the slack and use our crimpers and heat gun to put on a butt splice connector. Next, we attach the ring terminal to the far right stud of the positive bus bar in the Lynx distributor, and then push the ferrule into the B1 terminal on the shunt. And this is just going to deliver power to the shunt. The data cable that comes with the BMV712 will go into the side of the shunt and into the back of the gauge that we're going to mount in a hole we drilled in the wall. Now that the wires are made and the Lynx distributor is pre-wired, we're going to go into the camper and attach it to the battery bank. We screwed the Lynx distributor to the wall and put the master disconnect spacers behind the switch and screwed the switch to the wall. Then we used the shunt spacers behind the shunt to screw the shunt to the wall. Next, we can connect our chassis ground wire. The chassis ground wire simply needs to go anywhere on the negative bus bar of the Lynx distributor, so we use this far stud as we had easy access to the frame of the camper immediately above. The other end goes to a plus nut that we put in the frame of the RV. This really just needs to go to any solidly attached piece of metal that is connected to most other metal framing of the camper. Next, we ran our wires from the Lynx distributor to where we mounted our battery on the other side of the pass-through wall and connected our negative wire to the negative battery terminal, and then connected the MRBF fuse holder to the positive battery terminal. Now we can run our data cable through the wall and attach it to our BMV712 monitor and mount it to the wall. And then we can open our Victron Connect app to program our BMV712. First, making sure the master switch is on, and the BMV712 should show up in the Victron Connect app. Tap to select, put in the default password, and update the firmware as necessary. And go ahead and just follow any other on-screen directions that it gives you. And once we're at the main screen of the BMV, tap the cog to access the settings, and set the battery bank capacity to 270 amp hours for the 270 amp hour battery that we installed. Auxiliary input to none, and then go up and press battery. And here is the cheat sheet that we're using for programming the BMV settings specifically to this battery. Change the battery capacity to 270 amp hours, and the charge voltage of 14.2 tells the BMV that the batteries are charged once they hit 14.2 volts. Discharge floor of 0% means that we can drain our batteries all the way to 0. Pukert exponent of 1.05, charge efficiency factor to 99%, and since we have nothing connected to the loads and chargers side of the shunt, we can also do a zero current calibration to tell the shunt that there is truly 0 amps flowing through the shunt, sort of like zeroing a scale here. Press back, miscellaneous, and none under auxiliary input. Press back, and then tap VE Smart Networking. Create a network so our charge controllers can communicate with our shunt, which we're going to show later. Go ahead and type in a network name. This can be whatever you like. And then back out all the way to the home screen. Now, how many of you have bought a component, had issues with it that were immediately resolved by simply programming and understanding how the component works? It's really important, so if you've had that experience, leave that in the comment section below so that everybody else can see how important that is. Now, I didn't get into why we chose the settings that we did, and that's because they're simply given to us by Battle-Born batteries. Those settings are very battery manufacturer specific parameters, and so if you're not using Battle-Born batteries, you're going to want to try to reach out to the manufacturer you've chosen to purchase from and see if they will give you their parameters for their batteries for the BMV712. With the Lynx distributor fully installed, we now have a great way to attach all of our components to the system. We can turn the system off and on with our master disconnect switch, and we can monitor our battery status with our BMV712 battery monitor. But the old crappy battery is powering the camper, so we need to fix that, and that's coming up next. We want to use our new battery to supply power to all the pre-existing wiring throughout the camper. But instead of rewiring every single component and branch circuit, we're simply going to supply power to the factory battery location so that all of the pre-existing branch circuits can remain as they are. The parts we're using in this chapter are from the EXPLORIST.life battery bank relocation kit. Using the barrel of the lug for our measurement, we stripped the insulation from one end of our positive wire and then repeated the process for the negative wire. Then we crimped on our wire lugs and then added heat shrink to the wire lug for a bit of protection and strain relief. And then we sanded our lugs and terminals and wiped them down with alcohol. The other ends of the wire are going to get lugs just the same, but we're going to do that out of the camper once we run the wires under the camper for a more accurate measurement of the wire length needed. We're having to run all of our wires underneath the camper for this and some of our circuits you'll see later in the video. And it's kind of intimidating to start pulling down this big massive sheet that's underneath the camper, but it's not that big a deal. It's a whole bunch of these self-tapping screws along the sides into the frame here. And then here at the front, right up here, is simply a bunch of spray foam that is sealing this membrane to the frame here. And just pulled that down with just my hands and my pocket knife. It wasn't too big of a deal. Now we have access to anything that we need underneath the camper. And whenever we get ready to button all this back up, we'll just put our screws back in place and go get a can of exterior rated spray foam and put the spray foam back where it was.
The junction studs from the kit are replacing the factory lead acid batteries, so we will unbolt those and get them out of the way. Bring the wires in from the Lynx distributor, then screw the junction studs in place. Put the new wires onto the junction studs. All of the wires that were attached to the positive terminals of the OEM batteries go to the positive junction stud, and the wires that were connected to the negative battery terminals go to the negative junction stud. This camper is a bit unique in the fact that it only has one positive and one negative wire coming off of the OEM battery bank. And so we opted to use junction studs for that reason, because we only have one wire to connect. Now, if you've got a bunch of wires coming off of your OEM battery bank, then you would want to instead use a bus bar like this so that you can connect them to each of these studs. Next, we're going to connect the wires to the Lynx distributor. First, I'm going to make sure my master disconnect switch is off. Remove the separator. Remove the nut washer and lock washers from the negative bus bar, the fuse holder stud, and the positive bus bar. Put the negative wire in place Replace the washer, lock washer, and nut. Break the little plastic piece off of the separator and snap the separator back into place. We'll place the mega fuse onto the positive bus bar and place the positive wire onto the fuse. Replace the washers, lock washers, nuts, and tighten. Now we can turn our master battery switch on, and we turn on some of our DC loads around the camper and see that they work perfectly. We can also check out our Victron Connect app and see the amperage used go up and down as we turn our lights on and off.
With the new battery wired to the pre-existing circuits, the camper is now operating with much more power. And if that's all you were after, you could actually stop right there if you had a lithium compatible converter. But we want to be able to power our 120 volt outlets from our new battery without having to plug into shore power, and that's coming up next. Wiring the Victron MultiPlus inverter charger so that we can power our 120 volt outlets from the new battery and recharge the battery from shore power is up next. But first, we need to splice into the OEM shore power inlet and breaker box, which can be intimidating. The simplest way that we can do this is to use the Splice kit that we've specifically designed for this purpose. The parts that we're using in this chapter are from the EXPLORIST.life 12 volt MultiPlus 2K wiring kit and the 30 amp OEM RV Splice kit. We measured and cut our wires, and using the barrel of the lug for our measurement, we stripped the insulation from both ends of our positive wire and then repeated the process for the negative wire and equipment ground. Next, we crimped on our wire lugs and made sure that the lugs were positioned on the wire so that the wire isn't twisted when installed. We added heat shrink to the wire lug for a bit of extra protection and strain relief. And then we sanded our lugs and terminals and wiped them down with alcohol. Next, we removed the cover of the MultiPlus. We cut slits in our wire glands on the MultiPlus and then put our red wire on the positive terminal and our black wire on the negative terminal. The equipment ground wire goes to the ground stud right down here with the serrated washer between the lug and inverter case. Next is the VE Bus Smart Dongle, which allows us to control the MultiPlus via Bluetooth on our phone. We have our RJ45 cable here, and one end goes to either of the VE Bus ports on our MultiPlus, and the other goes into the VE Bus Smart Dongle. These two wires are going to simply connect to the positive and negative power terminals of the MultiPlus on top of our big 2-aught wire lugs. The red power wire goes into the battery positive terminal, and the black power wire goes into the battery negative terminal. Now there's some double-sided tape on the back of the dongle, and we're simply going to stick it to the side of the MultiPlus. And the cover won't go onto the MultiPlus like this, so we're going to cut another hole and run the cable through. Next, we measured and cut the 10-3 wire from the EXPLORIST.life Splice kit and stripped back the outer sheathing and the wire insulation. Then crimped ferrules onto each of the wires. Now these go under the strain relief clamps inside of the MultiPlus, and one is going into the AC input, black, green, and white, to the L, PE, and N terminals respectively, and the other is going to the AC output, black to L, green to PE, and white to N. Now we're going to label each of these wires with what they're attached to in the MultiPlus so that we can connect them properly in the camper. The other end of both of these wires are going to the junction box from the EXPLORIST.life 30 amp OEM RV Splice kit, which we're going to go ahead and pre-assemble here on the tabletop. Now these terminal blocks we have here have a lip and snap lock and simply pivot up and into place on the DIN rail. Now these are basically glorified and more user-friendly butt splice connectors and pass through power from top to bottom. The order of which these are installed doesn't matter very much, but you should just have one of each color on each side, just like we've got here. Now with the MultiPlus inverter charger pre-wired and the Splice kit assembled, we're going to move this into the camper to mount and wire everything in place.
We fastened the MultiPlus mounting plate to the wall, put the MultiPlus in place on the mounting plate, secured the mounting screws at the bottom, and then replace the cover. Next, we're going to connect our wires to the Lynx distributor. First, we're going to make sure the master disconnect switch is off, remove the separator, remove the nut, washer, and lock washers from the negative bus bar, positive bus bar, and the fuse holder stud. Put the negative wire in place. Replace the washer, lock washer, and nut, and tighten. Snap the separator back into place. Place the mega fuse onto the positive bus bar, the positive wire onto the fuse, and replace the washers, lock washers, and nuts, and tighten. Next, we're going to put the equipment ground wire on the center stud of the negative bus bar in the exact same way we just did with the negative wire. Ideally, this MultiPlus would be mounted upright for best cooling, but in this particular camper, we have some space constraints and there's really nowhere in the camper to mount it upright. So we've mounted it sideways, and at the end of this installation, we're going to stress test it and see if we need to add some additional cooling for it. Next, we're going to connect the Splice kit to the OEM wiring. We're going to run our wires into the floor, pull them through the underbelly of the camper, and then pull them up into the cabinet behind the breaker box. We verified that we have no AC power in this system as we're not connected to shore power, and we've used an AC voltage detector to test a known live circuit, then tested the wire that we're about to cut. We're going to splice into the OEM wiring at this point, and the wiring from the shore power into the AC breaker box is coming in through this drawer back here, which is teeny tiny space to work in. So we've actually drilled a hole over here underneath the dinette seat, and we're going to install our splice kit right down here. We're going to be cutting into the OEM 10-3 wire that goes into the back of the breaker box. This will give us a wire that's going into the breaker box and a wire that's coming from the shore power inlet. We're going to connect the wires coming from the shore power inlet and the wires going to the breaker box to their respective sides of the splice kit. Which side goes to which doesn't really matter as long as everything is labeled properly and connected like shown in the diagram. For the wires coming from the MultiPlus, we stripped back the insulation and crimped on our ferrules. Then the wires going to the AC in on the MultiPlus get connected to the shore power inlet wires, and the wires coming from the AC out on the MultiPlus go to the breaker box. Here's a graphic of what that looks like. We screwed the splice kit to the floor, put the cover in place, and added some labels for added clarity. Lastly, you'll want to disable your OEM converter. In most campers, there's a converter breaker in the breaker box. We've simply turned this off and put a piece of tape across the breaker to indicate that it should not be toggled back on. If the converter is left on, then when you aren't connected to shore power, the batteries would be powering the MultiPlus inverter, which would power the breaker box, which would then power the converter, which would power the batteries, which would power the MultiPlus. And this is just a big circle of power loss that turning off the converter fixes.
Now let's test it out. We can turn our master battery switch on, turn the inverter to on, and then test some of our 120 volt loads. Our batteries are powering our MultiPlus, and our MultiPlus is powering our breaker box, which is powering all of our 120 volt loads. Now for this system, the air conditioner fan will come on, but the air conditioner is too power hungry for our inverter. Powering an air conditioner realistically needs a much larger system, and this will be a limitation of a system of this size. Now we can go plug into shore power, and the inverter will automatically switch over to powering the system via shore power and charging our batteries with the remaining power, which we can now see on our BMV 712. If we used a 30 amp to 15 amp adapter to connect to a standard household outlet and use the Victron Connect app connected to our VE Bus smart dongle to turn our shore power input current limit to below 15 amps so we didn't overload that circuit and trip the breaker, and turn on a heavy load like the air conditioner, the Power Assist feature from the MultiPlus would take the power available from shore and then invert the remaining power needed from the battery bank to power that load from an underpowered shore power connection. Now you'll notice that we did not program the MultiPlus inverter charger. That's because it was already programmed over at our warehouse. If you buy your MultiPlus inverter charger through us from our shop, we will program it for you if you're using Battleborn batteries. Now, if you're using a different brand of batteries, we'll still sell you the MultiPlus, but you will have to buy an MK3 USB programming dongle and get with your battery manufacturer of choice so that they can share their parameters for the MultiPlus with you. With the Victron MultiPlus wired, we are now able to charge our battery from shore power and power our 120 volt outlets from our battery. But in order to be a true off-grid rig, we need to be able to charge from solar, and that's up next. This camper came from the factory as solar ready, which does not mean that you can just put solar panels on the roof and call it a day. In this chapter, we're going to install solar panels and a charge controller and show you how to use the factory solar-ready wiring so that we can charge our new battery. The parts we're using in this chapter are from the EXPLORIST.life 800-watt solar charging wiring kit for 12-volt battery banks. We measured and cut our wire, and using the barrel of the lug and ferrule for our measurements, we stripped the insulation from both ends of our positive wire and then repeated the process for the negative and equipment ground wires. Next, we crimped on our wire lugs and made sure the lugs were positioned on the wire so the wire isn't twisted when installed. And then crimped on our ferrules. Now these just clean up the wire ends so there's no stray wires to cause a short. We added some heat shrink to the lugs and ferrules for a bit of extra protection and strain relief. And then we did the same for our smaller 10-gauge wire. Then we sanded our lugs and terminals and wiped them down with alcohol. We put the red 2-gauge wire into the battery positive terminal and the black 2-gauge wire into the battery negative terminal. And then the black 10-gauge wire into the PV negative terminal and the red 10-gauge wire into the PV positive terminal, and torqued all of those terminals down to manufacturer spec. The 2-gauge equipment ground wire connects to the side of the charge controller with the serrated washer between the lug and the heatsink and the washer and lock washer on top. Next, we're going to remove the 2 plugs out of the solar isolator and remove the cover and replace the plugs with the wire glands from the EXPLORIST.life solar array wiring kit. Now with the charge controller pre-wired and the isolator pre-assembled, we're going to move into the camper and mount and wire everything in place.
We fastened the charge controller to the wall. Next, we're going to connect the wires from the charge controller to the Lynx distributor. First, we're going to make sure the master disconnect switch is off. Remove the separator. Remove the nut, washer, and lock washers from the negative bus bar, positive bus bar, and the fuse holder stud. Put the negative wire in place. Replace the washer, lock washer, and nut. Break off the little plastic piece from the separator. Snap the separator back into place. Place the mega fuse onto the positive bus bar. Place the positive wire onto the fuse. Replace the washers, lock washers, and nuts, and then tighten. Then we attached the equipment ground wire to the equipment ground stud on the MultiPlus. We mounted the solar isolator to the wall with screws. We loosen the screw terminals and put the 10-gauge wires coming from the charge controller into the bottom right 2 terminals. And put the 10-gauge wires that will go to the pre-existing solar wires into the top right 2 terminals, matching red to red and black to black, top to bottom, and replace the solar isolator cover. This camper came pre-wired for solar, but it has 2 wires coming from it and they weren't labeled, so we weren't sure which one was going to the OEM battery bank and which one was going to the roof for the solar panels. So we grabbed our multimeter and we checked the voltage for each of these wires, and we found that one has power and one does not have power. So the one that does have power is the one that's going to our battery bank. And we're just going to go ahead and cap that one off because we've already run our wires for power going to the Lynx distributor. The one that does not have power is what's going to the roof for solar. So we're going to butt splice those wires onto the wires that we have running to our solar isolator.
Next is time for solar panels, starting with mounting our solar panel Z brackets to the panels with the included hardware, and then repeating that 4 times per panel, and then move them all up onto the roof. And before moving them up onto the roof, we're actually going to make sure that the solar isolator is off. And up on the roof, we added some 3M VHB double-sided tape to the bottom of each bracket. Then moved our panels into place, traced around our Z brackets, and then cleaned a spot on the roof with alcohol. Removed the paper from the tape, put the panel in place, secured the bracket with large self-tapping screws, and then repeated the process for every bracket of every panel. Most of the wires on the backs of the panels will reach each other as well as the factory roof entry gland, but the furthest one would not. So we needed to make an extension wire with a male connector on one end and a female connector on the other end. Now we have a detailed video on making these connectors that we're just going to link to in the video description. All of these panels are getting wired in series, which means that the positive wires are connecting to the negative wires of the neighboring panel, and then the positive and negative wires from the entire array are connecting to the PV connectors at the roof entry gland. Now, here's how that looks in a graphic form that's easier to see. With everything wired and our clamps in place for wire management, we came back around with some sealant to put over and around all the mounting feet to seal up the screw holes from the top, as well as over the screws for the wire clamps. Now we can go back down into the camper, program the charge controller, and test it out. We're going to turn the master battery switch to on, and turn the solar isolator to on. If we open the Victron Connect app on our phone, we can now see our new charge controller on the list. Tap the new charge controller, update the firmware as necessary, and then follow any other directions on screen. Once we're on the charge controller home screen, we can already see that we are actually producing power. Click the cog in the top right to bring up the charge controller settings. Tap battery. And here are the changes that we're going to make for our 270 amp hour 12 volt Battleborn battery. Set the battery preset to user defined, expert mode to on, absorption voltage to 14.6 volts, float voltage to 13.5 volts, since these batteries don't really need to float, equalization voltage to 14.4, and equalization is normally higher, but since these batteries don't need it, we're actually going to be turning it off, and 14.4 volts is low enough that if something weird were to happen, an equalization voltage of 14.4 won't hurt the batteries. Adaptive on absorption duration, and 30 minutes per 100 amp hours of battery, which rounded to 300 means an hour and a half for our 270 amp hour bank. A tail current of 2 amps, and then leave all the equalization settings as default. Just make sure that automatic equalization is disabled. And then tap temperature compensation and turn that just off, since these batteries do not need their charging voltages to change based on temperature like lead acid batteries do. And our batteries have built-in low temperature cutoffs, so we can just leave this as disabled. And then everything else can stay as default here, except for VE Smart Networking, which we're going to click into and tap Join Existing Network, and then select the network we created earlier with the BMV712. And I have several networks on my phone, so this looks kind of confusing, but if this is your first Victron install, you'll probably only have one here, which is very nice. And now we can back out to the home screen, and we are charging up nicely. The History tab is actually going to be your best friend here when trying to see how much power that you've made and your max power achieved on a day-to-day basis. Then in preparation for the next step, we can turn off our master battery switch. Now we have fully functioning solar charging, but we also want the option for alternator charging for long drives at night or during cloudy weather, and that's coming up next. For alternator charging, the 7-pin connector is so slow that it's really not even worth having. So we're going to install a dedicated DC to DC charger and show you some tips on how to make the quick connection at the hitch. The parts we're using in this chapter are the Victron Orion DC-to-DC charger, the EXPLORIST.life Orion DC-to-DC charger wiring kit, and our quick disconnects. Now before we get started, there's a little green jumper pin in the Orion box. We are going to need this later, and it's very important but easy to lose. Don't lose this. Tape it to the front of the charger so you don't lose it. It's important. We measured and cut our wire off camera, and then using the barrel of the lug for our measurement, we stripped the insulation from our positive wire and then repeated the process for the negative wire. Next, we crimped on our wire lugs and made sure that the lugs were positioned on the wire so that the wire isn't twisted when installed. And then crimped on our ferrules. And these just clean up the wire ends so there are no stray wires to cause a short. And then we added heat shrink to the lugs and ferrules for a bit of protection and strain relief. Then we sanded our lugs and wiped everything down with alcohol. Now, all of the wires are made, and this looks kind of messy, but just refer to the diagram and keep watching the video and I'll make it make sense. And now we can wire the Orion DC-to-DC charger. We put the short red 6-gauge wire into the positive output terminal, the short black 6-gauge wire into the negative output terminal, put the long red 6-gauge wire into the positive input terminal, and the long black 6-gauge wire into the negative input terminal. With the Orion pre-wired, we moved into the camper and secured it to the wall with the output wires going through the floor where they would run up to the hitch. Next, we're going to connect the output wires to the Lynx distributor. But first, we're going to make sure our solar isolator and master disconnect switch is off. We remove the separator, remove the nut, washer, and lock washers from the negative bus bar, positive bus bar, and fuse holder stud. Then put the negative wire in place, replace the washer, lock washer, and nut. Break the little plastic piece off the separator, and then snap the separator back into place. Mega fuse onto the positive bus bar, positive wire onto the fuse, and then replace the washers, lock washers, nuts, and tighten. Next, we can crimp Anderson connectors onto the Orion input wires that we've already run under the floor, through the underbelly of the camper, and up to the hitch. We strip back the insulation, crimped an Anderson pin onto each wire, and then push the pins into the housing, paying special attention to the positive and negative marks. Now for the wire going to the engine start battery, we started in the engine bay and fed our wire down and under the truck, keeping clear of hot or moving parts, and secured it in place with plenty of zip ties and cable clamps as necessary. And at the hitch, we added the other half of the Anderson connector in the exact same manner as the other one, paying special attention to the positive and negative label on the housing. And then we attached the housing to the bottom of the bumper with some machine screws, washers, and nylock nuts. For the starting battery connection, we connected the negative wire to the negative battery terminal and the MRBF fuse holder to the positive battery terminal, and then put the fuse, wire lug, washer, lock washer, and nut onto the fuse holder and tightened it down. Now we can connect the Anderson connectors from the truck to the camper, turn on the master battery switch, and then open the Victron Connect app for programming. Tap the new Orion charger, update the firmware as necessary, follow any other on-screen directions, and then click the cog in the top right to bring up the settings. And here are the settings that we're going to change for our 270 amp hour 12 volt Battleborn battery. First, change the function to charger, and then tap battery settings. Select user defined for the battery preset, absorption voltage to 14.6, float voltage to 13.5 since these batteries don't need to float, turn on adaptive absorption time, and the max absorption time should be 30 minutes per 100 amp hours of batteries, which rounded means an hour and a half for our 270 amp hour bank. The default settings should work for everything else. Now we want to put the little jumper pin in the bottom of the Orion so it can actually function. And now we can see that our Orion is actually in the bulk charging phase, and see that power coming in through the BMV712. Now, if we turn the solar isolator back on, we can actually see some solar power being added to that. Now, we can leave solar, alternator, and shore power all on at the same time, as they're all going to automatically regulate and synchronize as necessary. Now, we also have a video where we installed dual Orions for alternator charging in our Transit if you'd like faster alternator charging, and we'll link to that video in the description below. Now Kurt and Lori have a self-sufficient off-grid travel trailer so they can get away from their NASCAR-loving friends. But if you have a different type of rig, we've got a whole video playlist of full installs on other types of campers, and we'll link to that and more down in the pinned comment.
If you want to upgrade your camper electrical system, consider buying from our store. We're a small business, and purchasing through us funds these videos that we make available for all of you each and every week.
We hope you found this video helpful, and if you did, it would be awesome if you would share it with somebody or a group who you think could use it. Leave any questions you've got or new things you learned in the comment section below. Subscribe if you want to see more videos like this one, and we will see you in the next video.